Question number 7. There are two coils and both the coils are identical and they are separated by a distance equal to radius of them. Then what is the magnetic field midway between them? And you need to understand one thing. If there is a coil at a distance x along the axis, because this point is along the axis, okay, then if its radius is r, this magnetic field here will be equal to mu naught n I r square, number of turns of the coil, current into radius square divided by 2 times r square plus x square whole power 3 by 2. And you see here, if the current is in the either clockwise or anti-clockwise direction, the magnetic field is along the axis, either in this direction or in this direction, depends on the direction of the current. And here in this case, what they have given is the current in both the coils are in the same direction. If, let's take the first coil, if the coil is having the current in this direction, then you know that magnetic field on this side will be in this direction, on this side will be in this direction. And if you place another similar coil or identical coil up here with the same direction of current, for this coil, magnetic field at this point will be reinforcing, will be in the same direction. Here it will be in this direction. We know that this distance of separation is r. So from this coil, this distance will be r by 2. From this coil, this distance will be r by 2. Radius of this coil is also r. Radius of this coil is also r. The current in this coil is I. The current in this coil is also I. The number of turns of the coil n. Here also number of turns of the coil n. Since both the magnetic fields are reinforcing each other, total magnetic field is B total, magnetic field due to this plus magnetic field due to this. Both are same. So if magnetic field due to this at this point is B, this will also be B. Both are in the same direction because magnetic field is a vector. If they are in the opposite direction, you have to subtract one from the other. So here the total magnetic field will be equal to 2 times the magnetic field produced by any one of the coil. So for this coil, the distance x is equal to r by 2. Then the total magnetic field will be equal to 2 times mu naught n I r square divided by, it's 2 times r square plus r by 2 the whole square whole power 3 by 2. Then total magnetic field B will be equal to, these two will be cancelled, so mu naught n I r square by r square, r by 2 whole square is r square by 4 whole power 3 by 2. This is equal to mu naught n I r square divided by 5 r square by 4 whole power 3 by 2. Here mu naught n I r square divided by r square whole power 3 by 2. If you take that out, r square whole power 3 by 2 becomes r cube. This r cube and r square will be cancelled. Then 5 by 4 whole power 3 by 2. So 5 whole power 3 by 2, 4 whole power 3 by 2 will be in the denominator. That goes to the numerator, 4 whole power 3 by 2. Then in this case, this 4 cube is 64, whole power 1 by 2 is 8. So this is 8 mu naught n I r square divided by 5 power 3 by 2 into r cube. So r cube and this square will be cancelled. So 8 times mu naught n I r divided by 5 power 3 by 2, and sorry, this r won't be there, this r got cancelled, divided by r. According to this, our option is B, 8 n mu naught I divided by 5 power 3 by 2 r.